This is Geometry, Unit 7, Day 4. We're going to talk about special right triangles. There's two specific type of triangles that we don't even need to know as much information about as we could for Pythagorean Theorem. Pythagorean Theorem, we need to have two sides to find the last side. But if we're going to work with a 45, 45, 90 triangle, we can even work with even less information. In a 45, 45, 90 triangle, we know that the hypotenuse is always going to be the square root of 2 times either leg. The extended ratio would then be considered 1, 1, and the square root of 2. There's a formula that we'll use a lot, and that's the hypotenuse equals the leg times the square root of 2. So to use that formula, we'll come down here. We're going to find the lengths of the missing sides. We know that this is a right triangle. If two sides are the exact same, we know that this is an isosceles triangle. And with an isosceles triangle, we'll know that both of these angles, therefore, have to be the same. The only way you can add up to 180 is if they're 45 and 45. So if this is 12, this guy has to be 12 because it has the same tick mark. Now we have to calculate what the hypotenuse is going to be. At this point, you could use Pythagorean Theorem, but there's a shortcut for that. Remember, across from the 90 degrees is your hypotenuse. The other two sides are the legs of a right triangle. But instead of setting up hypotenuse squared equals leg squared plus leg squared, we know this new formula, which is the hypotenuse is going to equal the leg times root 2. So we don't know the hypotenuse. We know the leg is 12, and we're going to times that to root 2. In most cases, they're going to ask you to leave it in radical form. So we know that the hypotenuse is going to equal 12 root 2. You don't need the decimal. Over here, across from the 90 degrees is your hypotenuse. If one of your angles is 45, one of the acute angles, we know that the other one is complementary to that. It has to be 45 also. So I have a 45, 45, 90 triangle. You need to identify what type of triangle you have first. So I'm going to use my formula. Hypotenuse equals leg times root 2. My hypotenuse is 6 root 2. I don't know what the leg is. You can put x there, you can put leg there, whatever. So now if I want to get that alone, I'm going to divide by the square root of 2 to both sides of the equal sign, and that's going to get my unknown side all by itself. And that meant that that unknown side would have to be 6. Both the legs would then have to be 6. And it makes sense now. If the leg is 6, the hypotenuse has to be 6 times square root of 2. Letter C. I see that I have a right triangle. We know that two sides are congruent to each other. Therefore, the two angles are congruent to each other, and that forces them in a right triangle to be 45, 45. This is your hypotenuse. We'll call these sides x this time. So if you have the hypotenuse, then the leg times root 2 is what equals that hypotenuse. The hypotenuse is 10. X times the square root of 2 is what 10 is supposed to be. To get the x by itself, I need to divide both sides by square root of 2. And I'm left with this 10 divided by the square root of 2. Well, we're not looking for decimals. And we know that it's not appropriate to leave a radical in the denominator. So now we have to rationalize the denominator. So we're going to multiply both by the square root of 2 to the top and the bottom. Square root of 2 times the square root of 2. When you're multiplying the same thing like that, you get what's inside. And then you're able to reduce. The two numbers that are not radicals you can work with. Or if they're both radicals, you could work with that. But a 2 cannot be reduced with the other square root of 2. So that's our hypotenuse. I'm sorry. It's not a hypotenuse. A hypotenuse is 10. So that's our value of x. That's our leg. So we have 5 root 2 and 5 root 2. Now some people get confused by this because they think that the hypotenuse has to be the root 2. But think about what is 5 root 2 times the square root of 2. One way to test that out, 5 square root of 2 times the square root of 2 is a value of 10. So I knew that the answer was correct. So again, my hypotenuse is 12. I have a 90-degree angle of 45, so I know the other angle has to be 45 because it has to add up to 180. So if I have a 45, 45, 90 triangle, I know that the hypotenuse has to equal the leg times the square root of 2. The hypotenuse is 12 for this problem. We'll call the leg x, and we'll call this leg x. So we have x square root of 2. We'll divide both sides by the square root of 2. That's so we get the x by itself. And now we have 12 divided by the square root of 2. So I need to rationalize the denominator to get 12 root 2 over 2, which is going to become 6 square root of 2, because I am simplifying out the 12 divided by 2. 6 root 2 is the length of both of the legs. And again, if you multiply 6 root 2 by root 2, you're going to get 6 times 2, which is 12, which is your hypotenuse. Okay, we'll jump over to the other side. Now another type of triangle that we're going to look at is a 30, 60, 90 triangle. In a 30, 60, 90 triangle, we have special relationships between the sides. This one's a little trickier because we have more angle that are different, so we have more sides that are different. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter side. So that makes life easy. We have the short side. Short side is always across from the 30. The hypotenuse is twice that long, or 2 times that amount. And the longer leg is always the square root of 3 times as long as a short leg. So notice, both formulas are based off of the short leg. You need to know the short leg to be able to figure out the other two measurements. So the hypotenuse is going to be 2 times the short leg, and the longer leg is going to be short leg times the square root of 3. Now notice, this one is square root of 3. In the 45, 45, 90, it was the square root of 2, so you need to remember which is which. This one has the 30, so I kind of remember to me that this is the square root of 3. They have 3 different angle measurements, so this one has a square root of 3. The 45, 45, 90 has 2 angles the same, so it's a square root of 2. Somehow you need to remember which formula goes with which problem. Okay, we're going to find the length of the missing side. Well, this is your short leg. We know that. because it's across from the shorter side. This is the long leg because it's not the short one. Across from the 90 is your hypotenuse. So if this is 30, this one must be 60 because it has to add up to 180 total. So we have a formula that says the hypotenuse equals the short side times 2. So I don't know what the hypotenuse is. The short side is 2 times 2. So the hypotenuse has to be 4. And then to figure out the long side, we know that the long side equals the short side times the square root of 3. So now I know the long side equals 2 times the square root of 3. So the long side is obviously 2 root 3. We don't need decimals. Most of the time they're going to say leave your answer in radical form. So here we're going to get 2 square root 3. So to figure out your hypotenuse, you multiply it by 2. To figure out your long leg, you multiply by the square root of 3. Now what if you're given the short leg first? Well, that's the short leg. We know this is the long side. What if we're given the long leg first? The short has to be across from the smaller angle. If this is 60, this angle has to be 30. Across from it is called the short side. So to figure out what the short side is, we're going to use the formula that deals with the long information. The long side equals the short side times the square root of 3. Same formula we used here. Well, the long side is 5 square root 3. I don't know what the short side is, but it's supposed to times the square root of 3. I'm going to divide by the square root of 3 to both sides, and that's going to cross them off. So now I have 5 equals the short side. And then we can very quickly figure out what the hypotenuse is. The hypotenuse equals the short side times 2. So the hypotenuse is 10. Now what if the long side doesn't have that radical 3? It makes it a little bit trickier to work with. So of course this is across from the 60, so this is the long side. That makes this 30, and across from it is the short side. Across from the 90 is of course the hypotenuse. Because I have the long side information, I need to use the formula that deals with the long side. So to do that, I'm going to plug in my long side information. I'm going to divide by the square root of 3. So that's going to leave me with 10 over the square root of 3. That's what my short side is. In terms of a decimal, I could just plug that right in. But if I'm supposed to leave it in radical form, then I should rationalize the denominator. So that's the short side. That's called 10 square root of 3 over 3. Now to figure out the hypotenuse, remember, is 2 times that amount. So the hypotenuse equals the short leg times 2. So the hypotenuse, I don't know. The short leg is 10 square root 3 over 2. Well, actually over 3, sorry. Times 2. here, the 2, if you want to think about it as a fraction, it would be 2 over 1. The 3 and the 1 multiply each other, and the 2 is going to multiply the 10. So we're going to get 20 square root of 3 over 3. And that is the hypotenuse. And our next question, we're dealing with a guitar pick. Well, a guitar pick is similar to an equilateral triangle. Equilateral triangle has all the same lengths. 32, 32, and 32. These would be in millimeters. So it's kind of a 3.2 centimeters. What is the approximate height of our pick? Now remember, if we have a point that is equal distance to the endpoints, then we know that it is equal distance, that it hits the perpendicular bisector. If it's equal distance to the endpoints, then we know it's on the perpendicular bisector. It's perpendicular because we want to know height. So now we're just going to look at one of these triangles. So we're going to look at this one triangle, which is 16, 32, and we're trying to figure out this side. Height is always perpendicular. Now, if you're paying close attention to the numbers, notice how this is 16 and the hypotenuse is twice that amount. It's showing the pattern that we worked with earlier. There's only one triangle that can produce that, one set of angles that's going to be possible. That's a 30, 60, 90 triangle. So if this is twice, then we know the long side has to be the short times root 3, so 16 root 3. That's the quick answer. You could use Pythagorean Theorem. That'll get you the same answer. But do notice this triangle must be a 30, 60, 90 triangle because the hypotenuse is twice the short side. So if it's a 30, 60, 90 triangle, then we say hypotenuse equals the short side, times 2. We know that one, sorry. What we don't know right now, perhaps, is what the long side is. The long side equals the short side times root 3. Well, the short side is 16 times the square root of 3. That equals the long side. So the long side is representing our height. So that is the height of the triangle. A car is turned off while the windshield wipers are moving. The 12-inch wiper stops, making a 60-degree angle with the bottom of the windshield. How far from the bottom of the windshield are the ends of the wiper? So we have a windshield wiper that is making a 60-degree angle The windshield wiper is 24 inches. It's making a 60-degree angle. How far is the tip on the way down? Well, if this is a 60-degree angle, this one has to be 30, which makes this the short side, this the hypotenuse, and this the long side. So I'm supposed to figure out the long side. I don't know. I can't go from the hypotenuse to the long side. I have to go through the short side first. So the short side, well, let's do this straight. We're supposed to say the hypotenuse equals the short side times 2. The hypotenuse is 24. The short side is 2 times that. So divide by 2. So the short side is going to be 12. Now if the short side is 12, I know that the long side is supposed to be the short times the square root of 3. So I know that the long side, the distance that it takes to get to the bottom of the windshield, is 12 times the square root of 3.